Okay, so this final section says write the equation and then find all the characteristics. So remember, when we write the equation, it's going to be y equals mx plus b. So we need the slope and we need the y-intercept. So for this problem, it's a little bit hard to kind of see and the dots and there's no grid. So we're just going to kind of estimate some numbers. So right here, I'm going to say that that went up 2. So my y-intercept is going to be a 2. And if we write that as a point, that is 0, 2. Okay, then I need to identify another point so I can do the slope. So I'm going to use that one, and I'm going to say that's at 1. So right here actually is also the x-intercept. So our x-intercept is going to be at 1, so that's 1, 0. So we actually have both intercepts already. Okay, then I'm going to need to find the slope. So the slope, remember, is rise over run. So I'm going from this point to this point, and I'm drawing my triangle. I have to hop down 2 and over 1. So my rise over my run for this problem is 2 over 1, but remember I went down, and down is negative. If you were a person, you'd be tumbling downhill. So now I have my slope, so let me go ahead and write that over here. So my slope is negative 2. Negative 2 over 1 is the same thing as negative 2. So it's going to be y equals mx is negative 2x plus b plus 2. Then it wants the domain and range. So remember, domain are your x values. So if I go left and right forever, does this graph stop? No, it doesn't matter if I go left, right, up, down. There's arrows on both, which means it's going to continue to use all of the x's on the left, all of the x's on the right, and it's also going to continue to use all the y's going up and all the y's going down. So your domain and range for this problem is negative infinity to infinity for both of them. That means there's arrows on the graph and it is just going forever and ever. Okay, let me make some space on this graph. Okay, then I have my end behavior. So your end behavior is always going to be increase, decrease, and these are given usually. On your homework worksheet, I give you those. So increase and decrease. So as x increases, those are all your positive numbers on your x-axis. As x decreases are all of the negative numbers. So as x decreases, that's the left side. So we're looking at this arrow right here. As x increases, we're looking at that arrow. So as x increases, that's this side of the graph, the arrow is going down, so it is decreasing. As x decreases, that's this side, it's going up, so your answer is increase. Okay, for this problem, I believe this is the line we're looking at. It's kind of hard to tell. We're going to say that this line is up here at 3. That's a 3. 1, 2, 3. So this line goes through the y-axis. So it's going to be y equals 3. So the slope it's a horizontal line. So if you remember slope man, Horizontal line is his mouth. That's right here. So his slope is 0. X-intercept, this is never going to cross the x-axis, right? Because it's up here. So the x-intercept is none. The y-intercept is 0, 3. Your domain, this graph does go left and right forever. It has a left arrow on it and a right arrow. So your domain is negative infinity to positive infinity. Your range, though, it's not going up and down forever. It is staying at that y value the whole time. So the range is a brace, 3, brace. And it tells you right here, y equals 3. That is your range. It is only 3. And then that same thing is with your ends, your end behavior right here. Your end behavior, as I go to the left, it's staying at 3. As I go to the right, it's staying at 3. It doesn't matter which side I look at. It's not going up or down. It is at